K.G. Subramanian. The peacocks are antisymmetrically located. The song Tagore talks about the Mondira of time, which is an incessant symphony shifting between the right and the left hands as though in constant search for harmonious hues of color amidst the conflict between black and white. My final example is about the cosmic dance of Nataraja that finds a special place in CERN, Geneva. Nittero Dale Dale Nataraj. Here, dance is a euphemism for wavy motion. In the words, Nritya Tomar Muktir Roop, Nritya Tomar Maya, Vishwa Tolute Onute, Onute, Kampe Nritya Chaya. We discern an Upanishadic message and at the same time the quantum mechanical principle of wave-particle duality. A molecule that is Onu, a particle constituent of matter that is Vishwatonu vibrates in the shadow of Nataraja's cosmic dance. Nrityer boshe Sundara holo Vidrohi Paromanu. The otherwise rebellious atom, the Paromanu, gets localized, another property of waves, the underpinning of the uncertainty principle of quantum mechanics. In Vishwaparichaya, the poet has written, physicists had earlier thought that when the worldly objects are reduced to a stage when they cannot be subdivided, we reach the atomic world. Atoms are so minute that 10 crores of them make a line of 1 inch. Physicists have now found ways of even breaking open the seemingly impregnable doors of atoms. When the latter are ripped apart, we obtain subatoms, namely electrons and protons. But what constrains these electrons within the vast empty space of atoms is the mass concentrated at the atomic center, the nucleus. Otherwise, the atoms would not have existed, neither would the world we live in. We now know that the elliptical path is referring to the Bohr atom model, that the elliptical path the electron follows, it not just one, but multiple. These orbits are at definite distances from the nucleus. The electron cannot come closer to the nucleus than the nearest orbit from the nucleus. It can, however, transit from one orbit to another, apparently without any predetermined reason. The electron can absorb radiation to jump from an inner orbit to an outer orbit, just as it can emanate radiation when it jumps from an outer to an inner orbit. As long as the electron is constrained to move in the same orbit, there is no emission of light. This theory is one of the basic principles of quantum mechanics that explains why an atom retains its structure, why the universe remains intact. Gurudev writes in Vishwaparichaya, Nityer boshe Sundara holo Vidrohi Paromanu. Rabindranath goes on to write in Vishwaparichaya, the fact that an atom is disintegrable has prompted physicists to devise machines that can send radiation deep inside the atom to probe its internal structure. The LHC in CERN is indeed a worthy successor to the machines that Tagore had alluded to. So you can see a few pictures of Nataraja adorning the CERN premises in Geneva.
Like Gurudev, I'm wondering whether you are a scholar, educationist, physicist, poet, and whatnot. Thank you for a very interesting presentation. And on behalf of all of us here, thank you for your book and your overall ideas on where Tagore touches each one of our lives. Thank you. I now request you to take my place here. I know.
But probably not more dangerous than Vice Chancellor's chair. May we now invite Shivaji Raha, Vice President also of the Tagore Center for Natural Sciences and Philosophy, to talk about the duality, the connections, the bonding between Rabindranath Tagore and Jagadish Chandra Bose. Shivaji. Thank you, Mr. Chairman. And it's a difficult task to hold people's interest after this extremely riveting talk. I had alluded to the subject of my discussion during the inaugural session 2 days ago. And that is the complementary role that J.C. Bose, the doyen of modern Indian science, and Rabindranath Tagore played on each other. The authentic, in my opinion, the best known biography of Rabindranath from the Western perspective is by Andrew Robinson and Krishna Datta, where there is one observation. The authors call Rabindranath a myriad-minded man, quite aptly, as has become obvious now. That the only person who was close to this myriad-minded man in practice as well as in spirit was the Bengali physicist J.C. Bose. J.C. Bose was 2.5 years older than Tagore. He died 3.5 years before Tagore. And people say that they were lifelong friends. And certainly, of the Bengal Renaissance, the three best known faces to the Western world are Swami Vivekananda, of course, because of his address at the Chicago Congress of Religions, World Congress of Religions in '92, and J.C. Bose and Rabindranath Tagore. Rabindranath Tagore was the first Asian to win a Nobel Prize in Literature. J.C. Bose was the first Asian to obtain an US patent for a device using semiconductors. Sir Neville Mott said that J.C. Bose was 60 years ahead of his times in his work. And in fact, I will come to this discussion in a little more detail in a minute. His work on plant physiology, which is actually a derivative of his work in electromagnetism, was close to 100 years ahead of their times. But J.C. Bose and Rabindranath Tagore both grew up essentially in Calcutta, in distances not more than 3 or 4 kilometers. They belong to the small religious order called the Brahmo religion, which is a part of Hinduism, was a part of Hinduism, but distinct. I don't want to get into the discussions of those. But there is no evidence that there was much interaction during their early youth between them. J.C. Bose got his undergraduate degree from Cambridge. He got his tripos in 1884 from Cambridge. In fact, incidentally from the same college that Vikas went to close to 100 years later, Christ College. And the same year he also got a BA from University of London. Came back and joined Residency College in Calcutta as a professor of physics. And for the first 10 years of his existence there was no evidence that he did any original research. He devoted most of his time to teaching, but at that time he made his mark through his teaching practices that he was the first person to incorporate actual classroom demonstrations as part of his teaching. Prior to that, there was no such practice. Father Lafont, a Belgian Jesuit priest who used to teach at St. Xavier's College, where J.C. Bose had his early undergraduate education, inducted that practice in J.C. Bose, and he made it his essential staple of teaching method, that he would teach primarily through demonstration of experiments. At the time of his 38th birthday, in 1896, J.C. Bose made an entry in his diary that from now on, I want to bring glory to my motherland through the pursuit of scientific knowledge and research. And within 6 months' time, he declared the solution of one of the most outstanding problems of the time, namely a Hertzian wave of millimeter wavelength, 5 millimeter wavelength. As the physicists here know, that since the announcement of the Maxwell's equation in 1864, people had been trying to prove the wave nature of the electromagnetic wave, and the first successful effort was in 1883 or 84, I can't remember the exact year, by Hertz, where he discovered a wave of wavelength 66 centimeter, almost a meter. Now, to show the birefringence property of a meter-long wave, you need crystals and prisms the size of this room. Okay. So everybody was trying to discover waves of manageable length, millimeters or so. And in 1896, in a demonstration, first at Presidency College and then at Town Hall, Calcutta, J.C. Bose showed that he could produce wavelengths of 5 millimeter, which could penetrate human bodies, walls, other obstacles, and send signals up to distances of close to 100 meters, 78 meters or so. Okay. So this was the first demonstration of wireless transmission of signals. He then got leave of absence from his teaching duties and went on a trip to the US, to UK, and at the British institution, Royal Institution, he demonstrated this phenomenon where Lord Kelvin, Lord Rayleigh and others were present. And he was hailed as one of the brightest stars in the firmament of physics at that time, because this was a problem everybody was trifling with, and they couldn't solve it. So he came back to India in a blaze of glory, and then soon after his return, he had a visitor, but J.C. Bose and his wife weren't at home at that time. So the visitor left a calling card. And the calling card was in the nature of a magnolia flower. So the visitor was Rabindranath Tagore. And it's this aesthetic appeal, bonding between the two, which led to a lifelong friendship, which enriched not only them individually, but the entire course of the evolution of the Bengal Renaissance, both in arts and sciences. And it would not be wrong to say that they both supplemented each other in both analytical thinking as well as aesthetic approaches. So after this initial introduction in 1897 or so, thereafter their friendship grew very, very fast. And Rabindranath was spending a lot of time in managing his estate in Shilaidaho, which is now in Bangladesh. So they had a vast property there, and Rabindranath was asked to manage that by his father. So he spent most of his time on a houseboat on the Patna. And J.C. Bose was a very regular visitor to him during the weekends. And historically, one sees that prior to this period, Tagore's literary activities did not amount much in the area of prose. He used to write songs, he used to write poetry, but prose, especially short stories, were not his forte. The biography written by Tagore's son, Rabindranath Tagore, called Pitri Smriti, Memories of My Father, he mentions these visits of J.C. Bose, and he mentions that it was at the insistence of J.C. Bose that my father would get into a frantic frenzy and pen down one or two short stories before Jagadish Babu would arrive, because otherwise Jagadish Bose would feel very offended and he would not repeat his visit. So every time Jagadish Bose was to visit Shilaidaho, Rabindranath would write at least one or two short stories and compose one or two new songs to present to him. Many of these stories really are among his masterpieces. And then in early 1900s, when J.C. Bose was spending a longer time in London, in UK, he and Tagore exchanged letters in which there are references of J.C. Bose's efforts to find a suitable translator who would translate these short stories into English and find a publisher for this. And then after a few letters, it just appears that the efforts to find a suitable publisher wasn't yielding much fruit at that time, so the project was dropped. Sushanta mentioned the formation of that before Vishwabharati became a university. In 1901, Rabindranath had started this alternative school in Shantiniketan, which he called an ashram. Because of Rabindranath's experiences in rural Bengal through his sojourn in Shalaidaho, and because of J.C. Bose's early childhood in Bangladesh, where his father was a civil servant, a deputy magistrate, who allowed the convicts of that area, the so-called petty criminals as well as the fierce criminals, to look after J.C. Bose. He did not put any restriction on the kind of company J.C. Bose would keep. So J.C. Bose had developed a very deep familiarity as well as fondness for nature. His early education, before he came to Kolkata and started schooling at Hare School and later at St. Xavier's Collegiate School, his early education was in the village school, and his essential teachers was nature. He got exposed to the so-called telegrapher plant, which once you touch them, they execute a rhythmic dance. There is also a very well-known species of plants in eastern India, which is called Mimosa pudica. In Bengali it is called Lajjavati lata. In Assamese it's called Lajuki lata. The characteristic is that if you touch these plants, they immediately fold, even if it's a long chain. These are features which intrigued J.C. Bose from his early beginning. And this is what will come back to his research many, many times. But to come to that in a few minutes, when in the early 1900s, when Rabindranath was starting with his Shantiniketan ashram, he was very conscious of the importance of technical education being a part of the curriculum in Shantiniketan. So he started talking about establishing a workable laboratory with a concept which was not available in India at that time at all, where the problems of rural life could be solved through technological means. And he consulted at depth with J.C. Bose, who was in England at that time, and sent him substantial amount of money